The law of universal gravitation, formulated by Sir Isaac Newton in 1687, is a fundamental principle in physics that describes the force of gravitational attraction between objects with mass. It revolutionized our understanding of the motion of celestial bodies and remains a cornerstone of classical mechanics. The law is often summarized by the equation F equals G*M1*M2/r², where F is the force of gravitational attraction between two objects. G is the gravitational constant, approximately 6.674 times 10 to the power of -11 and m²2/kg². M1 and M2 are the masses of the two objects, and r is the distance between the centers of their masses. Key points of Newton's law of universal gravitation. Gravitational attraction. The law states that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Inverse square law. The force of gravitational attraction weakens as the distance between the two masses increases. Specifically, the force decreases in proportion to the square of the distance. This means that if the distance between two objects is doubled, the force of attraction between them decreases to 1/4 of its original value. Symmetrical interaction. The force of gravitational attraction acts along the line connecting the centers of the two masses and is directed towards each other. In other words, both masses attract each other with equal and opposite forces, as stated in Newton's third law of motion. Universal application. The law applies to all objects with mass in the universe, from small particles to celestial bodies like planets, stars, and galaxies. It governs the motion of planets around the sun, the moon around the earth, and the interactions of celestial bodies in space. Independent of mass and composition, the gravitational force between two objects depends solely on their masses and the distance between them. It does not depend on the object's composition, density, or any other physical properties. Dominance of large masses. For everyday objects on Earth, the force of gravity is relatively weak. However, when dealing with celestial bodies with massive masses, such as planets and stars, the gravitational force becomes a dominant factor in shaping their motion and interactions. Newton's law of universal gravitation provided a unified explanation for the motion of celestial bodies, overcoming earlier ideas of separate laws for celestial and terrestrial motion. It is a crucial foundation for understanding the mechanics of the solar system, the behavior of galaxies, and the interaction of cosmic bodies on a grand scale. The law's profound implications and accuracy have stood the test of time and continue to shape our understanding of the universe.